Here's our last graphing problem for 4.5 day 1. We're going to do a secant graph, but you'll notice it's a little different this time. We are introducing some transformations here. So we're going to see a different period, we're going to see a little bit different height on this graph, and I want to walk you through how that all works. First of all, let's figure out what the period is. The period in this case has to do with it 2. Now normally, as we've talked about, the period is going to start, the basic one, if it's not modified, is 2 pi. But we are having it modified here. We're dividing it by the 2. So in this case, our period is going to be pi. Well, on this graph, I already have the points labeled, but I kind of want to keep the size of this graph. I don't want to scrunch it down. So here's what I'm going to do instead. I'm just going to cross that out and call this pi. So this value is pi. I'm going to make this value pi over 2, and I'm going to do the same thing over on the other side. And so I'm going to make this one negative pi instead. That to me will make it a little bit better as far as scrunching it all in. All right, now we want to graph, since it's secant, we want to do the appropriate cosine graph for that one. Noticing that negative 2 is in front there. So normally with cosine, we would start at 0, 1. But in this case, it's multiplied by negative 2. So we're just going to multiply that 1 by negative 2, and we're going to start down at negative 2 for the cosine. So we have our starting point right here. And then we're going to go with the pattern going back and forth. It's just going to be flipped from what it is normally. So the important points are going to be, the only place to go is up in this case. So we go here, then we go to the max, then back down, and we repeat the pattern over on the other side of the graph. Also, like before, let's put in the sketching aid with dotted lines. If it's dotted, that means it is not a part of the graph, but it guides us for graphing, for sketching the actual graph. All right, then we are going to put in the vertical asymptotes. Again, right where they cross, right where this graph crosses the x-axis. So you'll notice my process here with the transformations is it's pretty much identical to the basic graphs. It's just that I've changed the period, I've changed like the labels on my graph there, and I've also just changed where I started the cosine graph. Otherwise, everything else is the same. From there, remember that these points at the tops and the bottoms are going to be a part of my secant graph. And then I just have to choose that one other point to get this shape. Now you'll notice here that this one's going down, so my first branch is going to be going down here. They're always going to be going opposite to the curvature of the sketching aid. So I'm going to choose the point that's right in here. Now we need to be careful about that point. We changed the labels here. This was pi over 2, so then halfway between 0 and pi over 2 is going to be pi over 4. And then halfway between 0 and pi over 4 is going to be pi over 8. And you might be doubting me a little bit here now because I told you in the last couple examples that somehow, some way, it's always going to be related to pi over 4, but it appears like it's not in this case. But stick with me because you'll see how that happens. So if we've got pi over 8, that's going to be our x value, and we have to plug it into this equation right here. So y equals negative 2 secant of 2 times pi over 8. And maybe you're already seeing where the pi over 4 is going to come in. That pi over 4 is going to be a result of the fact that it's 2 times pi over 8. So what's going on in here is that simplifies to pi over 4. And so now we get negative 2 secant of pi over 4. Now if you watch the last examples, you'll remember, hopefully remember, that the secant of pi over 4, we already figured that one out. We already know that the secant of pi over 4 is square root of 2, so I'm going to assume that detail. I'm going to leave the negative 2 out in front, but then this part becomes just square root of 2. So we've got 2 square root of 2 as our value now, as our y value where this thing's going to have a curve in that first branch. So not a bad idea to get the approximate amount. This will be about negative 2.8 when we're graphing it on here. So I'm going to extend this one extra tick mark on each side. That'll help us out with the values. So pi over 8, and then negative 2.8, that'll put it right about there. And I'll do a symmetric point on the other side, and that's going to be right about there. And then we can connect the dots like we did before. We're going to mirror this up here. Point halfway in between is about positive 2.8 and positive 2.8. And you might be thinking about this as being really repetitive. If you watch the last two examples and this one seems really repetitive, that's probably a good indication that you understand what's going on in this problem. So if this seems pretty boring and repetitive, that might just be because you understand it well, and I hope that's the case. But we'll finish this up. Get the negative 2.8 down there. So again, we have a couple of half periods at the end, and that's okay because it gives us a total of 4 branches, 2 full periods. And then like before, I would like you to label that one point that we found, which we used pi over 8 as the x value, and we found out that it was negative 2 square root of 2 as the y value, and that will be some evidence to show me that you've graphed this by hand. So that is the last piece with the transformations. Cosecant's very similar, but the way that we do the process is going to look the same just about every time here. So hopefully that gives you a little bit better picture of how to graph secant and cosecant.